Hello baby, let's get started with TensorFlow with zero installation. So we'll use something known as Collaboratory for this. Okay, Collaboratory is a Google's platform to write TensorFlow code on cloud without having zero installation on your system. So for that, just search for Collaboratory. Okay, click here, Collab Research Google. We'll click here. Okay, we'll ask you for notebook, new notebook and all. Okay, it might take some time to approve you, but what will happen after that, we'll get a notebook type of environment which is available in the cloud itself. Okay, so this is the notebook that we'll try to understand now. We will get started with TensorFlow with zero installation, nothing required on your machine. Okay. Okay, so first is importing TensorFlow and versioning. Okay, to understand what is the version of TensorFlow we're trying to use. TensorFlow is currently running in 1.4 version, so we'll check whether the version that Collaborator is providing us is the same or not. Okay, click here. Okay, we'll see this. Okay, import TensorFlow STF. What is happening here? We're importing TensorFlow STF, and the version we want to check. To execute, Shift Enter. You'll see this circle happening, and you must see this connected here. Okay, so this will tell us that this is connected to some backend in Google Cloud. Okay, then the version we want to check. Okay, so it shows us 1.4.1, which is apparent to the latest version of TensorFlow that is available. So yes, great, we are using the latest version of TensorFlow. Now let's do some hello world and get understanding of things around that. Okay. So what we are doing here, we are creating a variable h, which is a constant, and it contains the word hello in it. Okay. Okay. Let's execute this. If it executes well, you'll see a number corresponding to it here. Okay. Then we want to create another variable w. Okay, which also points to a constant world. Shift it. Okay. Now we want to do append between this operation h and w, and this is what we execute. Okay, great. Now we want to see the contents of hw. If it is regular Python, it would probably show you hello world, but this is not the same with TensorFlow. TensorFlow believes in delayed execution. Okay, what is delayed execution? Execution will be delayed until you call session run associated. So if you simply do this, it will just create a place for this. It is not doing the operation as of now. This is the delayed execution concept of TensorFlow here. Okay. So what is it doing here? It is just creating a placeholder. It is telling the type here, and that's pretty much it is doing. Now really we want to see the contents of it. To do so, what we have to do is we have to create a session, and we have to execute this graph that is created here. So as of now, what has happened, you have created a h. Okay, you have created w. Okay, and you have had a plus operation here. Is getting data from here, getting data from here, and it should actually create something hw here. Okay, so this won't execute until you really call this guy. So tf session. Tf is a TensorFlow reference. Tf dot session as session. Then inside this scope, okay, inside this scope you're calling rest is equal to the variable in which you want to hold the value, session dot run, and then you pass hw, then you pass this guy. What will this guy do is it will execute the entire flow. I mean, this guy is dependent on this guy is dependent on this guy, and these two guys come together to this append operation, and then it executes. So let's see this. It will execute. Okay, now if you want to print the value, what has happened out of it, you print the value of rest. You'll see the data that is getting executed. So understood, right? You create the variables. Okay, in this case it is constants. You do the operation, that is what is happening here. You execute them by calling the last value that you want to execute in the session variable. All the dependencies is resolved internally, like hw is dependent on h, hw is dependent on w, everything is resolved internally, and finally you get the value like this. So this is apparently hello world in TensorFlow. Welcome to TensorFlow world, guys. Okay, let's see this graph sessions and fetches. Okay, what does it mean? So as you can see here, this is nothing but creating a graph here, and this element is dependent on this and this. So this is what is called dependency management in TensorFlow. Okay, to execute this, it finds what are the dependent nodes and it executes them. Okay, and the resultant is coming in here. Okay, let's see this. So what you're doing here, we're creating three TensorFlow tensors. Okay, these are known as tensors, A, B, and C. Three tensors. A is a constant, B is also a constant, C is also a constant. Let's execute them all, A, B, and C. Okay. Then we see here we have D, E, and F. D is actually multiplication of A and B. Okay. So D is dependent on. So let me clean this up. Okay. So we have A, we have B, we have C. Okay. Then we can see here D is dependent on A and B. Okay. E is dependent on B and C. Okay. Then you have E is equal to B and C. So here the operation, I mean, here the operation is uh, here in D the operation is multiplication. In E the operation is plus. The output is D and E respectively. So this D and E, okay. Then again it is it's creating an F with an operation of minus here, right? So this is how the graph, so far the graph is created, looks like this. Okay, this is the default graph. When you do all these things in the default scape, okay, it gets added to the default graph as you see like this default graph. Okay, now let's see. Okay, you want to execute this, so you can see here everything is dependent on this F. I mean, if you execute F, all of this data gets executed. So let's first execute this line, of course. Okay, then let's come here. Okay, this guy gets executed. Okay, now you want to see the output of it. What will be the output? The output will be value of F. Okay, let's see this. It is showing 18 in this case. Okay, now you want to see the default graph where everything is getting added. So to get, so this will print you the default graph, tf.get default graph. Okay, so this is printing the default. You can see the address wherever you want to check the graph and you want to check whether this is default graph or some other graph. This is the information that will be passed along with it. Okay, so if you want to create a new graph which is not part of default graph, the way you will do is tf.graph. This will create a new graph for you. Okay, this is the default graph's address. This is the new graph, and you can see here if I print the new graph's address, it should be different from the default graph. You can see the address over here. Okay, now what you want to do, you want to create some variable inside this default graph, inside this new graph rather than the default graph. Okay, so what you do is you can use with operator with g.asDefault. That means inside this scope, G will be treated as a default graph. So when you do A is equal to constant 77, so this is getting added to graph G here, and you can print here a.graph. Okay, so it will print you the G graph address. You can see here 8888. Okay, understood the concept of graphs here. Okay, as you can see, application can have multiple graphs. Then you'll go to fetches. Okay, what does fetches do? You click here. Okay, so fetches is like, we want to get all the values that is executed in this entire graph. So I'm just putting it all in one shot. Okay, you can see all this stuff here. So now what you want to do, you want to get values of all this data here. You can create a list. Of course, the name can be anything, and you pass this list in the run function. So it will actually return the list of all these values. Okay, list of all these values, as you can see here, print outs. Okay, it will, yeah, you can see here, this is the value of A, as it will maintain the A, B, C, D, E, F. Okay, F is a 30 in this case. Okay, based on all these operations that has happened over here. Okay, this is the concept of fetches. Let's proceed to the data types. Or as you can see, so by default it will be float. Of course, you can mention the type specifically. Okay, by mentioning D type is equal to information. You can of course do a casting here. This is the data, and you're casting it into integer variable, integer 16. D, if you put D now, D is a D type. So D type is a way by which you can pass any of the data type information. Now we'll see, various ways of creating arrays. For example, we have this is your NumPy, right? Import NumPy as NP. Okay, what you're doing here, you're creating. You can see here what you're doing here. You're creating a NumPy array, and then you're creating a tensor object from NumPy array. Okay, so you can definitely create tensor from numpy to tensor. All the things are possible. Okay, now let's see. You want to, of course, when it becomes a tensor, you cannot get the value directly. You have to execute session.run. Okay, that is what will happen here. You have this session.run here, session.run. Okay. Okay, so it might happen in case, but let's see what is wrong here. You actually haven't declared this D here. So first you have to execute this guy. Okay, then you have to execute this guy. Okay, you can see the output coming in here. Okay, so what is it doing here? It is actually, okay, so you have this guy. So let me explain what is happening over here. Okay, let's start with tensor arrays and shapes around it. Okay, let's see. So first is we are creating a numpy. This is importing numpy. Okay, we are creating a numpy array, and you can see you are creating a tensor object from numpy. If you want to execute the same guy, okay, this guy, and you do this. Okay, let's see this. So what will you do? Let's start with tensor arrays and shapes. Okay, so what will we do here? We have this linspace. Okay, what is linspace doing? This is the starting point, this is the ending point, and this is the number. So between the starting point and ending point, it is generating 20 numbers. So as you can see here, so with tf.session as sess, okay, out is equal to session.run and d. So what will it do? It will show you the data that is generated here. 20 data is generated between 1 and 10, as you can see here. Okay. Okay. We can do a few more things. If you wrote dot, okay. So we have this range, give 10. Okay, so what is it doing? It is generating. So if I do this, if I want to see the data, tf is equal to range, then just do this with tf dot session as sys out is equal to sys dot run t. If you want to see the value of t, it will be like this. Right, we can see the data that is getting generated here. Okay, let's see more things around it. Okay, so you have tf dot once. Okay, then okay, then you might have, okay, so in case you're not sure of the syntax, sometimes you can make use of this help guy. Okay, come here, we do tf once. Okay, it will tell you the syntax here. Tf once is the size of it and the type of it. Okay, so you do this tf once. Okay, size of it, you precisely want 4 cross 4, and type of it tf dot 16. Okay, So this will create a tensor. Again, if you want to get the value, you know what to do, right? You do this. Okay, so as you can see here, uh, every time you want a value, you have to execute the graph. This is creating the graph, and you have to execute the graph. So TensorFlow basically works in two stages. One is creating the graph, one is executing the graph. Creating the graph starts with creating the nodes, building relationship, and then to execute the graph, you have to do session.run. Okay, so this was like getting started with TensorFlow. We'll try to implement linear regression using TensorFlow in our next round. Thank you.